Today we are going to discuss about the definition of integrated circuits and the difference between linear and digital ICs. So the integrated circuit is defined as a miniature low-cost electronic circuit that consists of both active and passive component fabricated together on a single crystal of silicon. So as I have already discussed, so the combination of active and passive components fabricated together in a silicon that is formed as a miniature electronic circuit is called as an integrated circuit, which is widely used in our day-to-day electronic applications. So it is having the active components, that is transistors and diodes, and passive components, that is resistors and capacitors. So the combination of active and passive components together fabricated in a silicon that is formed the miniature electronic circuit called as an integrated circuit. So billions and millions of transistors are embedded into a silicon chip to form an integrated circuits, which deals with many application and many audio processing, video processing applications. So these are all the pictures of integrated circuits. So if you see, so this is an LM555 IC. So it is an mainly used for square wave generator, that is multi-vibrator. We will discuss in later sessions. And this is IC741 IC. So that it is commonly called as operational amplifier IC. So it is normally an 8-bit IC. So which is having inverting input and non-inverting input, and followed by biasing and input and output terminals, etc. It is normally an 8-pin ICs. So this is the image of ICs which is inside our PCs and other electronic gadgets. So unlike the digital ICs, so the digital IC you have previously studied is having 14 pin, and that is dealing with zeros and ones. And this analog ICs, it is linear IC, are having only 8 pins in miniature in size. It is embedded in this inside the silicon chip. The many thousands and millions of transistors are embedded. And these are all the types of ICs commonly classified as linear or analog ICs. And second one is digital ICs, which is dealing with the digital input and output, that is discrete. And this is dealing with the continuous input signals, commonly called as linear or analog ICs, which produce the linear relationship between input and output. So as the figure shows, linear or analog ICs, so the input and output are proportional to each other. So whatever you are producing the change in the input, which is replicated to the output. For example, if you increase the value of input by 2, automatically the change will happen in the output also. So that is the linear relationship between input and output. So this is an operational IC, that is linear IC. So this is digital IC. So you might have studied in your digital circuits. So there will be a logic gates. It is a 14-pin IC. So the 7th pin is normally connected to ground, and 14th pin is normally connected to VCC, that is supply of 5 plus 5. Sorry. And this is the 3-pin IC, that is 2 input and 1 output. So similarly, multiple ICs are there. It is dealing with zeros and ones. The high shows the 1 and the 0 shows the low input, and similarly low and high output accordingly. So this classification of ICs are majorly important in case of ICs. So generation of digital ICs deals with different strategies according to the number of transistors inside. It is commonly classified as SSI, that is small scale integration ICs, MSI, that is medium scale integration IC, LSI is called as large scale integration, and VLSI, that is very large scale integration, and VVLSI, very very large scale integration, WSI, commonly called as wafer scale integration, and nanotechnology. So these integration ICs are mainly dealing with the number of components and the size of ICs. So this comes under the generation of digital ICs. So according to the different generation of ICs, we can scale that ICs. So that is, with a small scale integration deals with 1 to 10 number of transistors inside it, and the medium scale integration deals with 10 to 500 number of transistors. And coming to the large scale integration, so 500 to 20,000 number of transistors are integrated inside the large scale integration, and very large scale around 20,000 to 10 lakh transistors. So, and an ultra large scale integration deals with more than 10 lakh transistors inside it. So the millions of transistors are inside in your single chip, with deals with the level of integration, that is scale of integration. So as commonly classified ICs are digital and analog ICs. So according to the different components, that is based upon applications we have seen so far, that is linear IC, this analog continuous IC, and digital IC, you know that zeros and ones, that is discrete inputs. And apart from that, different classifications are there. So one is based upon the fabrication techniques. So how the ICs are fabricated, that is monolithic IC and hybrid IC. So the next topic is about fabrication techniques of ICs. In that topic, we shall discuss these monolithic and hybrid ICs in detail. So just now we can able to identify the classification according to the fabrication techniques is enough. So monolithic IC and hybrid IC is based upon the fabrication technique and based upon the technology. So what sort of transistors are used inside your ICs? So based upon that technology, we can classify into two types, that is BJT and MOSFET. It is BJT, bipolar junction transistor, and MOSFET, metal oxide semiconductor field effect transistor. As we already know that BJT is a current controlled device and MOSFET is a voltage controlled device. So when the output is controlled by the input current, output voltage is controlled by the input current, then the technology comes under current controlled technology, that is BJT. When the output voltage is controlled by the input gate voltage, then the technique comes under field effect transistor, voltage control technology. So which type of transistors are used inside the ICs? So that classification is dependent upon the technology based. And the next final thing is based upon the device count. So device count, as we have already seen, according to the transistor count, it is varied from small scale integration to the ultra large scale integration. So advantages of integrated circuits is, hence it is a miniature in size and increased equipment density. So millions and billions of transistors and active passive components are there. So the equipment density is increased, and the cost reduction due to batch processing, and the reliability of the system increased. Hence the soldered joints are eliminated in this integrated circuits, and the functional performance of the ICs is increased much, and increased operating speeds and reduction in power consumption. So the limitation of integrated circuits are, as the IC is very small in size, it is in the nano size. So the very large number of large amount of passive components are there inside the ICs. Hence the small size of IC is unable to dissipate a large amount of power. Hence the heat of the ICs may get increased. So the next is increase in current may produce heat and it may destroy the device, since the size is very less and we cannot able to dissipate the large amount of power outside. There is a possibility of increase in current and it may destroy the device. And coils, inductors, transformers cannot be fabricated in the IC form. That is the major disadvantage of integrated circuits. So in this lecture, we have discussed about the definition of ICs and different scales of ICs and different types of ICs and how the limitations and advantages uh, are having in the inside the integrated circuits.